good conversation. It happens to be the day after the election, and only 12 hours or so since the race was called. If this room is representative, there are many, most of the people in this room voted for Kamala Harris. Some of you may be feeling great sense of disappointment, maybe fear, anxiety. If so, it's great that you can be here tonight. I happen in my personal devotions to be going through the book of Daniel. And Daniel, from the first page to the last, is about God being sovereign over the nations, over the affairs of men. Daniel writing to a people who had lost their country and were living in exile. And so perhaps with that thought, if you're here tonight and just feeling unsettled or more, maybe with that thought we can turn our attention to another topic that is very important for all of us involved in technology, and by God's grace have a good and encouraging discussion. So what I was hoping to do tonight, and this might be a little bit different from the other talks we've had here. We've had someone from the venture capital community come and talk about raising money for a venture. The talk today is really more focused on practitioners of technology. How our work as software engineers and in related disciplines can express the image of God in us. So Chris mentioned that the faith in FaithTech is the Christian faith. We believe in a God who has created us. And I've been thinking for some time about how work in our industry might connect to the image of God in us. So broadly speaking, I think this talk is relevant to, directly relevant to anyone in any of these fields. Broadly, anything that involves coding. If you're a QA engineer, you might use Selenium, a Java-based framework, to write your tests. In data engineering, you might use Python. In DevOps, even in the infrastructure world now, there's a tool called Terraform that's used to code up infrastructure deployments. So any of that, anyone who's involved in one of those types of jobs, this might be relevant. UX designers typically don't work in code, but UX designers often have to build design systems, a complex design system that needs to scale. And so there's a lot of system-related thinking in UX design. But probably this talk will be most relevant to software engineers in the room. Who in the room is a software engineer? Okay, great. But hopefully this is something that can be helpful to all of us. What I'm hoping to do is, as you do the work of a software developer or something related, a lot of the ideas that I present might sort of be there in the background. You might, just in the natural course of doing your job, as you relate to your colleagues, these things may come up. But what I would like to do is give a more concrete set of ideas that capture what the nature, some aspects of doing this work, and specifically how those ideas can relate to how God has built us. So with that, let me dive in. Just a couple of things about myself, so you know who's talking to you tonight. I've spent about 20 years in application development and support, but you'll notice that I'm not a developer. I was a history major in college. I took a Java class in the evening, and at that point realized that software engineering was not for me. But I've spent many of these 20 years working in software with teams to deliver software in the financial industry. I was at JP Chase for 15 years, where I got my start and did a lot of work for the fixed income trading desks. As a consultant, I've continued to work in the financial service industry in various other domains as well. And one thing that perhaps is worth mentioning is I've only worked in financial services. I've never worked at one of the big tech companies. Zach, a friend here, in speaking to him about his experience at Amazon, I think there are certain benefits to working in pure technology companies that you sometimes miss in financial services, where technology really is viewed as a cost, right? You need the technology in order to trade or what have you, and it's really viewed as a cost center rather than as a product that's going to generate revenue. And so that ties in a little bit to my experience. There are various, and please, I'd like this to be interactive, so if you have any questions at any point, feel free to just raise your hand and let's make it a bit of a conversation. So there are, these are the three main, again, as in the course of my career, I was, again, a history major, no clue whatsoever that I'd be spending this much time in the technology industry. And throughout that time, in thinking about how I would be able to serve the Lord through my work, I've been trying to think concretely about how my work relates to my faith. And these are three books that have been important to me in that task. Matthew Crawford is a guy who is on one hand a political philosopher, has a PhD in political science, but also did a lot of work fixing motorcycles. And this book, Shop Class as Soulcraft, is meant to talk about how skilled manual labor, to talk about the value of skilled manual labor, especially as in today's world there's so much of so-called knowledge work. In The World Beyond Your Head, there is a really fascinating chapter about the manufacturing of organs. The big pipe organs that you sometimes see in big churches. A truly fascinating chapter on what goes into building an organ. And I had come across that chapter somewhere and literally for years tried to then find which book where that chapter was found, and was gratified to finally find it in this book. After Virtue is a philosophy book, which there's a page of it right in front of you. Later on, I'm going to ask you to read that page. But a lot of Crawford's ideas are based on some core ideas in McIntyre's philosophy. So, how many of you developers in the room would, when you think of your work, would you say that it's a craft, or there's craftsmanship involved in your work? What? Okay. So this is just a quick quote from Crawford's book. What is craft? So one thing he wants to avoid is this, the craft of Japanese, making Japanese katanas. Maybe you've seen that. We want to stay away from something as sort of maybe mystical, like that, and think about our work in software engineering as something we do day to day. So he will sometimes use the term trade as opposed to craft to express that this is something that it's a job, it's not a hobby. And I think also very important is that we do this as our work. Someone is paying us to do this job. It's not a hobby that we do on nights and weekends. And so even as we think about our job as a craft person, we have to remember that somebody is paying us. There's deadlines to be met. It's a practical economic thing as well as being something, like making samurai swords. And one other key concept with a craft is that there's a standard, an external standard that governs what we do. In thinking about these types of jobs, what would be excluded when we think about jobs like this? A manual job, like the person who will come here in a couple of hours and clean up after us. Maybe that type of work, as valuable as it is, we wouldn't typically consider something that involves craft, perhaps. And also other types of complex work that maybe don't involve a set of standards. So maybe something like management, which we know is a complex job. There are tons of books written about how to manage a team, manage a company, but that might also fall outside the realm of craft, perhaps, because there isn't necessarily an external standard by which we would judge the quality of the work. If you think of carpentry, there are objective standards by which you can say that you've made something level, that you've made it square, that it's plumbed to the ground. External standards by which the quality of your work can be measured. And one of the things that I would argue and would ask you guys in the room to consider is whether that's also true of software engineering. To get to this idea of craft in software engineering, here's just an excerpt from a blog post that I found literally just a few days ago. Someone who argues that most programmers are actually bad at programming. And he is talking about frameworks. So perhaps if you do front-end development, something like React. If you're a Python developer, something like Django. Frameworks that are designed to make it easier for you to produce working code. But he argues that maybe there is now too much of a reliance on these things, and there's now a generation of developers that don't really know how code works. They just know how to build something in a framework. And in the end, that could just end up generating a lot of debt, making the code not as extensible in the future. Any thoughts on that, especially from the developers in the room? Yes, sir.
I guess just random thought. This is something that the concept has been said over the course of decades. Long time ago, when everybody programmed in pure byte code and assembly, and then C came out, and people were like, "Oh, this is a crutch. Why are you leaning on this and not just doing raw code?" And then something beyond C, like C++ came out, which was then more abstract from C, and then he said the same thing. Not saying he's wrong, but that's kind of what pops into my head, that the idea that every abstraction is necessarily wrong or a crutch.
Mm-hmm. Okay. Any other thoughts? Do you guys just build code from the ground up, or Anyone use those types of frameworks in their job day to day? Haley, what do you do? What do you use?
I would use React, Redux, and some other middleware that we customize a little bit.
Right, right. What's your take on this this statement here?
I understand that perspective, but I do think having more tools makes you more productive.
Yep.
So, if you have an IDE that does syntax highlighting, that helps catch errors and become a better programmer faster. And then you have GitHub Copilot, and so I think that's gonna, a generation or two, or even 5 years ago, engineers would have said using some type of AI assistant to help you code would be, that's a crutch, but I think it's going to be widely adopted and maybe make more engineers a lot more productive.
So that's what this fellow, and I don't really know who he is, I just came across this blog post. So the benefit of these tools is that it's lowering the barriers of entry, right? You don't need to take the gentleman's, what is your name, sir? Yeah.
Matt.
What Matt was saying, you don't need to manage memory pointers in C++ anymore, something that was traditionally a big challenge in development. And so there are, the barriers to entry have dropped. More people are able to build working code faster. But what has that done to the craft side of programming? Like, do you understand what the code is doing if you're just focused on the framework? Is that something that you guys grapple with in the course of doing your job?
Yeah, because sometimes, like, if something isn't working, you do have to dive into the framework and figure out why it's behaving a certain way.
Okay. So then, we have at my company a gentleman, one of our big clients, like many in the financial industry, or have as their standard the Angular framework for front-end development. And he views himself as a student of the Angular framework, over and above, writing code in TypeScript. Having to learn the ins and outs of the framework itself is a task for him. And then I guess when you need to understand why something's not working within the framework, then that could be an opportunity to really delve into how this code is working. Yeah.
I think it also depends on the user though too, because depending on the user, somebody who's really a craftsperson, they'll understand the framework, they'll understand the underlying principles too, and they'll really be a craftsperson with regards to understanding those, and they get some results out that may kind of make sense, but they'll have the craftsmanship to really understand, okay, there might be something here, and be able to dig deeper. But there might be other people who maybe aren't a craftsperson, who just put some information in, they get a result, that okay, it looks okay, time to go to the next thing. So it also depends on the user and their really, maybe it is more passion, how interested they are in really the craftsmanship of what they're putting together.
Okay. How does this connect to who God has made us? God made us, and what we read in Genesis chapter 1, I would submit, indicates, it shows us a God who himself is building a complex system. This is a representation of the so-called framework hypothesis of Genesis chapter 1, where in the 6 days of creation, we see that in the first 3 days, God is creating space, dividing, creating light from darkness, water above from water below, land from sea. And then on the second set of 3 days, days 4, 5, and 6, he then goes and fills those spaces he created in the first 3 days. So the light, sun, the moon, and stars on day 4, birds and sea creatures and birds on day 5, and then on day 6, the creatures that live on land. This, I would suggest, it shows us that God is a God who is building complex systems. The last book I'll recommend to you is a book by a guy called Stephen Meyer, who argues from an understanding of DNA. It's an argument for intelligent design, that when we look at DNA and how not just DNA itself, but the mechanism that surrounds DNA, that it is just almost impossibly unlikely that that system came up out of the random processes. There are various approaches whereby people can argue that life on Earth spontaneously, or not spontaneously, but arose without an intelligent designer. And it's a 500-page argument for why that is really, really, really unlikely. And I just noted here because one interesting thing is that as the discovery of DNA actually coincided with the rise of computing. A lot of this research took place at Cambridge University. Watson and Crick were students there. Cambridge is also the place where Alan Turing was a student, and it's fascinating how the code of life, DNA, a code with four bases, also arose alongside digital computing. Something I'd recommend for summer reading if you're interested. I'd like to ask you to take a few minutes to read this chapter, or this page from McIntyre's book. Okay. I struggled with this text. I realized some of it may not be immediately accessible, but the first couple of paragraphs just a practice, a complex activity. I think software engineering easily qualifies as something along those lines. Hopefully the analog between chess and software engineering makes sense. That the work of software engineering, building a highly complex machine, is you can imagine the connection or the analogy between that and the advanced game of chess. The idea of internal goods. Any of you developers, are you guys familiar with this idea of that sometimes we use of flow? Flow in engineering, right? How would you describe it, Lee?
I think it's a more general like psychology term, but
Yep.
basically you are just so concentrated and in the zone of working on something and solving something that you just kind of forget about your environment and the time, and time just flies.
Would you say that you have had that experience in your work?
When I don't have a bunch of meetings scheduled.
Right. So there's the idea of flow in software engineering. One friend that one friend describes it. He uses test-driven development, TDD, for some of you, and for him, that's a way of facilitating that experience by setting up a whole series of tests that fail at the outset, and then one by one knocking out those tests. He finds that's a way that gets him into that mindset. And it's a highly satisfying experience when you can solve a complex problem. Something that is only one way is only you can only experience that in a particular way by solving these complex problems in code. What would be, and not only are there that experience, but there are, as I mentioned earlier, guidelines or standards to the work of software engineering or the craft of software engineering. And what might some of those things be? So obviously your code has to work, but as we talked about, there are many tools available to help you get working code out. That's obviously no small feat. For us, when we do it as part of our jobs, there are business people and product managers who are trying to get you to hurry up and get it done. So obviously, getting working code is something we need to do. But if we look beyond that, code ought to be readable. Again, I'll ask you guys, for the engineers in the room, it's said that versus writing code or whatever else, the thing you spend most of your time doing is reading code, often someone else's code, and trying to understand that so that you can fix a bug or extend it. Is the code that you write readable to someone else? Is that code scalable? Maybe it works when you test it yourself, and maybe your QA guy or girl tests it, but is it code that when it's under load with thousands of people using it, is that code going to scale? And is that code extensible? Have you written it in such a way that someone who comes along later is going to be able to understand that code and without excessive fear of breaking everything, are they going to be able to make changes to it in response to evolving customer needs? we use the term often spaghetti code, that is maybe code that works, but is not readable, is not extensible. Maybe it won't perform under load. As you, I would ask you guys again, as you do your work, as you grow in your skill as a software engineer, are these things that become more important, right? Your code works great, but I'm not going to approve this pull request because it's just not, it's not clean and it's not written cleanly enough. So we're going to make the guy or gal go back and rewrite it so that other people can read it more easily. What do you guys, what would you say? Is this relevant to your experience? What would you say? Anything specific, Zach?
I've been guilty of that.
So someone has made you go back and rewrite things?
Yeah.
Yeah. Okay. So there's an ethic that is that's present in software engineering. We can now come to the idea of agency, and this is a concept that's important to Crawford. In becoming more skilled in software development, growing in your craft, coming to the point where you realize these internal standards of good code, even if beyond just getting it to work. As you grow as an engineer, you might also, in this craft, you may develop a greater sense of agency. And by this, Crawford means the ability to make a difference in the world. For him, it's the ability to take any old motorcycle that someone brings into his shop and have the confidence to know that he can fix that motorcycle. For us in software development, I think that this sense of agency can arise when you know that you are good enough, that you have enough experience, that you know enough about the actual workings of software in these frameworks and outside, where you can go in and clean up a bad code base. You can come in and have the confidence to, if the team is struggling, to come in and then play a role in the team such that you can stabilize the team's velocity and then hopefully eventually speed it up. That if customers or users are complaining about the number of defects that the team is putting out, then you can go in and given enough time, improve things such that the team's morale can improve, that a project that customers are unhappy with, you can turn that around and make them happy. As we grow in our craft, in our trade as software developers, hopefully this sense of agency can arise. And I think that this is something that connects to this idea of formation that we talk about sometimes in churches, that when you are doing the work of software development, when you're conscious of these internal standards, like not cutting corners, not checking in spaghetti code, that you're insistent on doing the job well, when you know you can do the job well and make a difference in your workplace, that's something that I should hurry up. That is something that gives you this sense of agency, and it's part of being formed as a believer in software engineering. Lastly, let's talk about aesthetic. And here, let me just play this clip.
Side note, let me say that Java is the language with which I first learned object-oriented programming, and with it, the art and science of software engineering. Also, early on in my undergraduate education, I took a course on concurrent programming with Java. Looking back at that time, before I fell in love with neural networks, the art of parallel computing was both algorithmically and philosophically fascinating to me. The concept of a computer in my mind before then was something that does one thing at a time. The idea that we could create an abstraction of parallelism where you could do many things at the same time while still guaranteeing stability and correctness was beautiful. While some folks in college took drugs to expand their mind, I took concurrent programming.
On this slide of aesthetic, I don't know that there's a picture that I could have provided that would convey what Lex Friedman is talking about. For those of you who don't know, Lex Friedman is a host of a well-known technology podcast. And he often, this conversation was with James Gosling, who's the creator of Java. And in many of his conversations, he asks how often someone who's done great work in computing finds their work beautiful. The last sentence of the passage from McIntyre says that only someone who is skilled in the practice at hand is able to be a judge of the quality, whether the work that's done measures up. Someone who is not skilled, someone who has no experience in that realm, is not qualified as a judge. I would also submit that if you are not a skilled software engineer, there's no way to even appreciate elegance or even, let's call it, beauty in a good software project. I could have put up a picture of an IDE with a bunch of code on it, but that's for me and other lay people. I don't think there's a way that we could apprehend an elegant, efficient software solution. What would you guys say? Like if you've come across a project that you think is really cool, that it solves the problem, a complex problem, solves it elegantly, efficiently, how do you come to that? How do you come to that appreciation? Can I pick on you, Lee?
Sure. I think it's just a matter of understanding what the project's trying to do. Like, so it's more so just understanding what the author, the engineer's trying to do, what the code's doing, taking a look at the code itself, making sure that I understand the code, that it's easy to read, it's easy to follow what's going on. It's not doing anything super weird. And when I say weird, I just mean like inefficiently, like doing a for loops or whatever.
Mm-hmm.
So it's all in all, it's just simply solve the problem in a way that's easy to understand.
Okay. And would you say that you've come across code like that and really had an appreciation for it, the ingenuity that's gone into writing that code?
Yeah, more so when I've worked on newer projects at work. Yeah, if it's relatively, if I started working on a small project or something, then it's easier to see that. But at bigger companies, whether they're banking or tech, you'll see more and more technical debt at the older projects are and the older applications that are out there. So most of the time I've seen like good aesthetically pleasing code, it's been like small projects or younger projects.
Have you come across a bigger system where you've most of the projects I've ever been on, any skilled developer comes to it and knows that it's loaded up with debt and it's going to take a long time to figure out. I have a few experiences where developers will come to a well-maintained project and say, this is code that I can work with. And they appreciate the hard work that's gone into creating and maintaining a clean and efficient code base. Anyone else have any experiences along those lines? An aesthetic experience when it comes to your work in software engineering? Okay, maybe they're to come in the future. So, what are some maybe practical thoughts on these concepts? If this sounds meaningful to you, that you can do your work in a way that expresses craftsmanship, quality, a sense of wanting to write code, good code for its own sake. Maybe bring those ideas of encouraging the experience of flow in the work. You can, as a team member, just bring that to your job day to day, working with your team members. I think team leaders have, as people with authority over the project, you're in a position maybe where you can start to talk about these types of standards. I can tell you that, and this goes back to my experience in financial services, many of the places where I've worked don't care about anything along these lines. Even for me, working at a company whose all we do is build software, there isn't much concern for the management aside from the client saying the job is done and they pay their invoices. Very little by way of encouraging growth in the task. JP Morgan, which is the company I spent most of my career, they have done some interesting things where typically in a bank, when you want to promote someone and give them greater recognition in the organization, you give them a bigger team to lead. And what was apparent before too long was that very good engineers are not always good managers of people. So they created a track whereby this expert engineer, distinguished engineer program, people who were very good technically, who understood the business very, very well, and made an outsized contribution as technical people would be recognized for that. And so perhaps in your organization, educating your clients or your business product managers or the business people that writing good code is not just about doing it as quickly as possible, that when you focus too much on just getting it out quickly, but build these spaghetti code-like projects, that's not good for the product in the long run. And if you are an owner or an entrepreneur, which is often the focus of our meetings here, I think you have a great opportunity to build an environment where people can have the freedom, have a little bit more time, maybe insist on a little bit less in terms of short-term profitability in order to give people a chance to do their work really well and build products that work well over time, that can flex later, where you can maintain a stable velocity in building new features. Something that owners and entrepreneurs have the special ability to do. And I would say, lastly, that all this ties into our mission as believers. That to do the work of software engineering really well in a way that contributes to the team around you, contributes to the future success of the project, when you're thinking about those things and behaving in those ways, that is in line with the way we as believers should be doing our jobs. And hopefully that creates opportunities with the people you work with to talk about your faith as well. All right. Any closing comments or questions? All right. If not, thank you all very much for the opportunity.